Okay, our next speaker is Michael Bailey, who has a really terrific name because it's 2/3 of my name. From the University of Michigan, he's going to talk about IPv6 adoption.
Okay, that'll be great. All right. Surprised to see so many of you still here towards the end. Appreciate that. I changed the slides last minute, not realizing that I couldn't change the slides last minute, so I'm going to interject some things that perhaps you won't see on some of these slides. What I'm going to talk about a little bit today is some joint work with a bunch of collaborators. Some of them are in the room. Danny and Eric from VeriSign, Scott from Arbor. Joint work with Mark Allman at the International Computer Science Institute out by Berkeley. A lot of this is driven by my graduate student, Jake, who couldn't be here today. I'll do my best to sort of represent some of the work that he's done. And Jake, if you're listening at home, you missed a pretty epic social last night. So the real motivation behind the work that we were looking at here is to try to understand at a very, very high level, a course level, what had been going on with IPv6 adoption. So one of the things that sort of struck us as we sort of looked at this problem was that there were lots and lots of data out there and lots of metrics about how close or how far we were along the path to IPv6 adoption. Oftentimes with multiple orders of magnitude difference between the numbers that were being reported. So the real approach here was to go back and step back from the process of adoption, look for some coarse-grained metrics, the things that we thought were most important in terms of reflecting where we are as a community moving towards this new protocol, and do some measurement and do some comparisons across the different protocols. So what we're looking at here is a variety of different data sets that we had an opportunity to use. Basically, this data is recent through the beginning of Q4 in 2012, so towards the end of last year. We are going to use a couple data sets that precede that time period, but we're again going to try to do some longitudinal studies, and again, up until about October of last year. Some of the data that we used is publicly available, things like the information that the RIR has put out in terms of allocations, routing information that you can get from route views or other looking glasses. Google makes public some of its IPv6 client adoption data. Arbor Networks was a collaborator on the work, and we're able to share some of their flow-based data for measuring traffic. VeriSign shared with us both some historic copies of the zone files for CommonNet, as well as a large-scale trace of the actual queries across a vast swath of their infrastructure for an entire day. We did some of our own hand probing of some of the Alexa top websites that we'll include as part of our analysis here today. The first metric that we looked at was this IPv4 and IPv6 prefix allocation. So the numbers here are the number of prefixes that we see allocated per month in both v4 and v6. We went back as far as the data was publicly available for us to go ahead and take a look at. We see time along the x-axis. This is a linear scale. Be careful of the y-axis scales. I'm going to switch back and forth between log and linear scale from time to time, depending on the size of the data that we're trying to take a look at. So one of the things that you're going to see throughout all the metrics that we have, and it's fairly obvious, I think, to everybody in the room, that at least at the current state of affairs, IPv4 dwarfs IPv6, so the IPv4 lines are all going to be towards the top here. Although one thing that you'll notice is that the slope of the v6 lines are always going to be much steeper than the slope of the v4 lines. And we'll talk a little bit about what that means long term for adoption. But here's the first metric that we're looking at here. Again, the total prefixes allocated per month. You can see a little bit of interesting activity around the 2011. This is all that activity around IANA's exhaustion event, and then the subsequent RIRs kicking off last allocation policies. The next metric we went and took a little bit of a look at was this IPv4 and IPv6 prefix advertisements. This is actually going now and looking at the route views data and asking of those allocated prefixes, what of those prefixes are actually being allocated out in the routing table. Here you see a huge difference. Again, now we switched to a log scale in terms of the number of actual prefixes that are being announced. Some small blips, again, around 2011, in part because of the flurry of allocation activity around then, in part also reflecting one of the two IPv launch events that were run. And we'll delve down a little bit deeper in some of those in just a minute. Another metric that we went and took a look at was the fraction of traffic that was native versus tunneled or encapsulated. So here we have two different lines looking at this metric. We have the data that we talked about from Google. Again, this is collected as folks are using the Google service. There's a little bit of a JavaScript. Google folks have a great paper on this a couple years ago, which I can point you to. A little piece of JavaScript that sort of determines whether or not this client could have reached Google via IPv6 had Google enabled IPv6 services. So that's the darker line on the bottom. The upper line is looking at the Arbor data. Again, this was a snapshot of 12 or so ISPs, 400 routers, a couple terabits per second peak traffic. These were the 12 service providers that are part of the Arbor Internet Observatory that were responding with v6 traffic, so had Flow enabled to report this v6 traffic. And so we see this downward trend in the amount of traffic that's actually not native traffic. Another way to have graphed this would have been to look at the increase in native versus tunneled or proxy traffic in some cases. So Google, we see the numbers approaching near zero. Arbor, we see still a great deal more tunneling, but certainly a downward path here. Another metric then we went to go look at was this idea of the naming infrastructure. So what we're looking at here is a longitudinal analysis of the zone files, and we're simply performing counting the quad A and A records for common net over time. And so we see this sort of upward trend, perhaps a little bit more steeply in the net traffic for the inclusion of quad A records in both of those zones. So then what we did is we took that trace, because of course it's not just enough to know that there's a capability to be able to look up the names. We kind of want to know how folks are querying that infrastructure. So we took that one-day trace, which is several billion queries across a large swath of VeriSign's naming infrastructure, and sort of tried to drill down a little bit to kind of better understand what it was that people were using the quad A records for. So here we're looking at just a summary table of some analysis of that data. The top row is looking at all the resolvers that were present in the trace that we saw. So these are, again, DNS-CAP packet traces, lots of different queries here. Of course, we don't expect that each one of those unique IP addresses that appear to be trying to resolve something is actually a resolver in the traditional sense of resolver. So we looked at the subset of those things which were active resolvers, and we asked the question, okay, what fraction of the resolvers that were out there in either one of these populations, either across the entire set or across this active resolver population, were actually querying VeriSign for quad A records, indicating that somebody was interested in at least some of that naming information. And we see numbers where at least almost 90% of that more active resolvers, the ones that we actually trust to be real resolvers resolving on behalf of clients, making those kinds of queries. This is one of those ones, it's going to be a little bit difficult to see from the back. What we did was looked at in that packet trace, we looked for what names were actually being queried. Okay? And then we compared those to what was being queried in IPv4. And gave some reference in terms of where they fell on something like the Alexia top N. So one of the things that I think is interesting to note is this third column, the A rank. So one of the things is this is the rank order in the top 1,000 for Quad A. So it's an interesting for A versus the Quad A, which we see in column 2 sorted. So this first item here, the first most popular request for Quad A records was the 6th most popular in A. And there's some interesting sort of, as you start to get down there by like number 10, you're looking at things that were like the 100th most popular or the 200th most popular thing in A. So it's definitely a different set of things that are being queried in IPv6. And again, I don't know if you can't see as many of the items there, but a lot of them tend to be infrastructure-related things. A bunch of the items that are on this list are either performance or measurement companies. There's a handful of people who are essentially using DNS as a big database. Blacklisting and reputation-based services figure very, very prominently in 6. They certainly exist in 4 as well, but not with such prevalence. In that same trace, we just drilled down briefly and looked at what the record query distribution was. Here we see about 10% of the total queries to the swath of the TLDs that we had access to were surfing for Quad A records. Okay. So then we kind of come back and look at some of the active probing that we did. So this is from a handful of locations around the V6 world. We probed the Alexa top N multiple different times during the week. We've sort of been collecting this data longitudinally for a while. 2 really interesting things to note here. We're looking, again, 2 lines on this particular graph. We have the whether or not we were actually able to resolve the Quad A record for the website that we were enumerating, and then whether it was actually reachable through IPv6 when we did our probing. 2 really big spikes. Those 2 spikes, those jumps, and then persistence afterwards are the result of the 2 IPv6 coordinated community activities. So a huge jump. I think the second jump there is a 4x jump in the reachability as the result of this community effort. This is looking at back to that Google data, the ones that they collect there on the server, and asking questions about who would have been reachable, how reachable they would have been. This is the fraction of clients that would have reached Google via V6 if V6 had been active. It's a fraction, not a percentage, so it sort of is peaking up there at about 1% of the clients would have been able to access had Google turned these systems on. For a point of comparison, I don't know how many of you are familiar with Jeff Houston's work out of the AP-NIC labs. They have a bunch of Google AdWords that they use to place measurement nodes in browsers, little JavaScript or Flash to go do this testing. Their results show that somewhere between 4 and 8% of the clients could reach various services via IPv6. So in the same ballpark, certainly a couple factors, certainly 4 or 5 times as much being represented there, but certainly not an order of magnitude difference. Now we turn back to the IPv6 and IPv4 traffic data. Again, this is back to the data that we've got from the Arbor Internet Observatory. This is the 12 or so customers that are currently reporting, voluntarily reporting this data to Arbor and that report V6 statistics. Again, like I said, 500 or so routers, about 1 or 2 terabit per second peak volumes. Now, the upper top, what we see is the volume of IPv4 traffic. On the bottom, we see the volume of IPv6 traffic. And in the middle, we see the ratio of the 2, V6 to V4. And we're going to use this technique for comparison frequently in the next couple of slides. But one of the very interesting things about this is, again, we see some significant bumps as a result of community activities around launch day and a interesting sort of doubling of the IPv6 traffic volume over the last year, up to what looks to be about 0.2% of the total traffic on the internet being IPv6 from this particular perspective. If you go drill down in the application mix that we see in the Arbor data, again, this is derived from ports. So, obviously a lot of the HTTP things, for example, are suspect because a lot of things are not necessarily web. But if you sort of look at the parity across IPv6 and IPv4, HTTP dominates. Now, this is actually quite different than some of the earlier traffic studies. We started to see people actually using IPv6 to do actually grab content. I mean, you saw Facebook up on the top. One of the queried Quad A records, Microsoft was up there as well. If you looked at these numbers, say 5 years ago, this would be dominated with backup traffic and DNS queries and pings. So it is refreshing to see that there's actual use of services, presumably client-facing services happening in v6 now. There still is a larger proportion of DNS in the traffic than we saw in the distribution of v4, as well as SSH and rsync. Again, this is all done by ports, so no guarantees that these are exactly matching up to these applications, but some indications that this is still has a lot of utility infrastructure being used. People are using this for management of their networks as opposed to as much of the clients actually using them for transit. So just sort of a snapshot, bringing together some of those IPv6 statistics that we've looked for so far. We see 200 plus IPv6 prefixes being allocated every month. That's about 20% of the total new allocations. Again, that line is steeper, although again, we're seeing more v4 allocations than we are seeing v6 allocations. The growth in the new allocations over time is much steeper for v6. There's about 100,000 v6 prefixes advertised per month from the route views data that we were looking at. That's about 2% of the total announced prefixes. Native IPv6 makes up about 75% of the IPv6 traffic mix, the rest of that being tunneled or encapsulated. The name servers, about 0.1% of COM and almost 1% of net servers that have A records also have Quad A records for them as well. 34% of the entire load in terms of unique resolvers, and 89% of what we view as active resolvers, things that are clearly doing resolution for clients, had at least one query for Quad A records. So they were getting at least one query from somebody behind them that was interested in that. The Quad A records are the third most popular query as observed at the TLDs, although the distribution of the domains tend towards things that look more like under-the-hood services than actual client-facing kinds of applications. 3% of the Alexa top 10,000 websites are reachable via IPv6 as of our measurements. Just under 1% of the clients could access Google via IPv6 if Google turned that service on. Peak IPv6 traffic is about 2% of the observed peak in IPv4. And aside from HTTP, which dominates in both, you're seeing a different sort of application distribution. So one of the things that I thought was interesting to go ahead and look at from some of those measurements was to sort of look at that data longitudinally and compare them across the various metrics, and then compare them also to IPv4. Because of course the networks are growing, there's demands for addresses, there's demands for new prefixes as things grow. You want to know whether or not 6 is growing pervasively faster across all of these metrics than 4 is. So what we looked at is for these individual metrics, the ratio of the metric in v6 to the metric in v4. Okay? So you'll see for the most part these are fractions. That again is the idea that the IPv4 lines are on top of the v6 lines. In spite of the fact that one's growing faster than the other, v4 still dominates. This sort of makes sense. Metric number 1 on the top is the allocation data. Metric 2 is the routing data. Metric 7 here is the DNS data. 10 is the traffic data. I think 4 is the glue records. I forgot to update that slide before I looked at it. So a couple things that I think that are interesting here. All of them are a positive upward trend. So if you take out the growth in the networks by doing the comparison between 4 and 5, everything is positively upward trending. So across every single one of these metrics, whether it's the allocations or the routing or the DNS infrastructure or the client readiness, growth in 6 is outpacing growth in 4. Another really sort of interesting thing about this particular graph is that kind of makes sense to me. right? So notice that, although the metrics can vary by several orders of magnitude, depending on what part of the elephant the philosopher is looking at, right? They all sort of fall in an order that at least makes some sort of natural sense to me. It makes sense that the adoption, the allocation is going to precede the routing, is going to precede, getting your naming aligned, is going to precede the actual traffic itself. So that seems to make some sense. It seems to give some idea for why we sort of see these disparate numbers being floated around, because it really depends on what part of this broad process you're part of. Not a huge fan of projections because I think they hardly ever come true, but we did do some curve fitting for both the top of that set of lines, which is the allocation, and the bottom set of that lines, which are, I think, were the glue records and DNS. So the sort of least prepared versus the most prepared in those slides. The left-hand side, you see some double marking or triple marking. That's the historic trend data up to that point, and then you see two lines coming off of each one of those sets of lines. One is an exponential fit, and one is a more polynomial fit of the curves that we saw identified on the left-hand side. Bottom line here is, again, try to choosing those bounding ranges that in the next 3 or 4 years, if these predictions hold, and we'll see, upwards of 20% of the allocations being V6, and we'll see upwards of 1 or 2% of the DNS traffic being V6 as well. Oops, went backwards. So that's sort of the question, the sort of analysis that we wanted to do. Again, our goal here wasn't necessarily to drill down deeply in any one of those metrics. I didn't want to go through talking about what region was growing faster than other regions. Other folks had done that. What I really wanted to do was make a comparison across the metrics and try to see why it was the case that, depending on who you're asking, we're almost there or we're really, really, really far away. So I think we have some time for questions.
Yeah, absolutely. Are there questions? Looks like John has a question.
Does this mic work now? Does this mic work? Okay.
Yes.
Hi, Michael. I guess I should say welcome back to NANOG after a somewhat extended hiatus. So you're a few changes from you up on the podium. The questions that you answered, the what and the how much were useful. I guess I had a question or a comment, if you don't have the answer, to the who. It would be interesting to look, I think, to see what the changes are from who were getting the allocations, if they were being used, so looking at, for example, the allocations, and then if they were being announced, and then perhaps being inserted into zone files or actually getting queries from that space. Can you say anything about trends, or can you identify ISPs that are experiencing some of the growth in IPv6? Is there anything to see there?
Yeah, so we didn't certainly go down to the ISP level, although I agree that's a very interesting question. And again, I won't go through each of the metrics because I think that question is going to be different depending on which of the metrics you're looking at. I do recall the data from the allocation in terms of absolute numbers. RIPE and APNIC are 1 and 2 in terms of the allocations, followed by ARIN, followed by, and I can't remember the order between LACNIC and AFNIC. In terms of the ratio, however, of V6 to V4, that list is inverted. So it's AFNIC and LACNIC who have a much larger percentage of their allocated prefixes in V6 than ARIN, who is way towards the bottom of that list in terms of the actual fraction. So that's one that I remember from allocation. Certainly would be very interesting to drill down with them into other metrics as well.
And just a reminder to two things as you ask questions: to state your name and affiliation, and to speak directly into the microphone so everyone can hear you. That was John Christoph of Team Cymru, by the way, who asked the first question.
Warren Kamari, Google, and I'm actually tall enough to speak into the mic for once. Can you go back to the slide that had the breakdown of ports and protocols?
I think so.
Yeah, that one.
Yes, this one, the application mix.
Yeah, so 14.1% was neither TCP nor UDP. That seems higher than I would have expected. Did you look what it was?
I can have Scott chime in since he gave us the data, and it's actually in V4 as opposed to V6, right? So my guess is that there's a bunch of GRE and other kinds of traffic in there. But Scott, you know the mix better than I do.
Yeah, hi, Scott Eichel Johnson, Arbor Networks. Yeah, the total other is partly data collection. We only added the other breakout by protocol in a later version of our software, so some deployments running older versions aren't differentiating TCP versus UDP, so they kind of just get lumped together into unknown or other. And then there is some non-TCP UDP protocol traffic.
Any other questions? Okay, thank you.